Now let us dig deep into the Internet protocol and Internet protocol version 4 addressing and subnet masking and these kind of things. So let's look into the some basic concepts uh, before taking up Internet protocol version 4 and then subnetting or subnet mask. So Internet protocol IP. So IP provides two fundamental network layer services. First one is logical addressing. Logical addressing provides a unique address that identifies both the host and the network that host exists in. And routing. Routing determines the best path to a particular destination network and then routes data accordingly. Then IP version 4. IP version 4 or Internet Protocol version 4 was the first version to experience widespread deployment and is defined in RFC 791. So Internet Protocol version 4 employs a 32-bit address. It's a 32-bit address. It consists of 32 bits. So which limits the number of possible addresses to only 4294967 so this much only you can have you cannot have more than that. Okay, so IP version 4 will eventually be replaced by IP version 6 due to a shortage of available IP version 4 addresses because IP version 4 can only have this much, only this 4294967 only this much of addresses it can provide. So that is the reason eventually we have to replace IP version 4 with the IP version 6. So now let's look into IP version 4 addressing, but it will take a lot of time. So IP version 4 addressing, a core function of IP is to provide logical addressing for hosts. An IP address provides a hierarchical structure to both uniquely identify a host and what network the host exists on. An IP address is most often represented in decimal format. You can see the format on your screen. So that is one example is 158.80.164.3 and I will show it, I will demonstrate it practically also. So let me come, this is EC2 global view. So let me get into EC2 service, anything, EC2 service. Just we can use anyone. So I'll go to the instances in Mumbai. So we have one instance that's running. You can see this. So example is this. Public IP is 65.279.11 dot and then private IP is 172.3016.243. So we have what is public IP and what is private IP. That's not very important for this moment. So now just look into how IP looks, the version 4. So version 6 is different completely, but how a version 4 IP looks like, you got it, 65.279.11. So here example we have taken is 158.80.164.3. so in this we have 4 octets. So each octet is an 8-bit number resulting in a 32-bit IP address. The smallest possible value of an octet is 0. A single octet, any single octet can have the smallest possible value of a 0. Like when all each octet consists of 8 digits. So if all 8 digits are zeros, then obviously the value would be 0. And the largest possible value of an octet is 255. If all 8 digits are ones, then the largest would be 255, 255. So in binary it's at all ones. So 0 to 255, this is the maximum possible values, minimum and maximum possible value of each octet. So based on this, because of this zeros and 255, so with that permutations and combination, we come up with this value 4294967 Now the above IP address is represented in binary. If you see this one, um, here this is first octet 158, second octet 80, and then third octet is 164, and then fourth octet is 3. So this is how it looks, and it consists of 4 octets, and total it's a 32-bit. I will show you how it is 32-bit. This is in normal language, so that it's octal. Now let us convert this into binary, and we'll see how does it look like. So each octet is an 8-bit number, so resulting in 32-bit IP address that you can see. First octet 1001110 and second octet is 0101 zeros. That's how you can convert a octal into binary digits. And the third octet and then fourth octet, if you count total how many bits, let me count it. One first bit, second bit, third bit, it has become 8-bit, and this is 8 bits, and this is 8-bit. 8 plus 8 plus 16 plus 8 24, 24 plus 8 bits, that is uh, 30 32. Yep. So total we got a 32-bit IP address. So this is how IP version 4 looks like. So now let's look into the subnet mask. Subnet mask. When I say the subnet mask, you might be confused with the subnet. No, not at all. Never ever get confused with the subnet and then subnet mask. The subnet is the hardware concept, and the subnet mask is the software concept. So what is the subnet? Subnet is the collection of routers and communication lines. That's it. That is your subnet. Whereas a subnet mask is completely a different concept. It's related to the addressing. It's related to the internet protocol. It's not at all related to the hardware concept. So this is called the subnet mask, and that is subnet. So the subnet mask is part of an IP address, so which identifies the network. So the other part of the address identifies the host. So if you see this total IP version 4 address, out of which one part will identify the network, other part will identify the host. So a subnet mask is required to provide this distinction. So now you got the difference. What's the difference between a subnet and then subnet mask? A subnet is a hardware thing. It's a collection of communication lines and then routers which are specific to one region. And then subnet mask is the one which makes the distinction between which part of IPv4 address is host and which part of IPv4 address is network. So the above, let's take this example one. So this address has a subnet mask of 255.255.0.0. So what does it says is, normally the subnet mask has only two rules, just two rules. If binary is set to a 1, if binary is set to a 1, Total we have 32 bit, right? We have 32 bits, right? In that, if binary is set to 1 in a subnet mask, the corresponding bit in the address identifies the network. If a binary bit is set to a 0 in a subnet mask, the corresponding bit in the address identifies the host. I think you are pretty much confused with this. Okay, don't worry, I'll just explain uh, on the on the slide also. So just take this example. So this is our address, this is our IP version 4 address, and then this is our subnet mask. That's clear. So if you look at this with octals, it's very difficult to understand the rules of subnet mask. What will we do now is we will convert this into binary form. So we'll convert this into the binary form. Looking IP address in binary form, this is how it looks. It looks total. It has 4 octets. So ones, zeros, one zeros, total 32 bits. Now let's look into subnet mask. Ones, and then second part all ones, and then third octet all zeros, and then fourth octet all zeros. Now what does it mean? So what does it mean is, for example, if you take any bit, I am taking the first bit of the subnet mask. The first bit of the subnet mask is 1, and then, so what it says is, if this is 1, the corresponding bit of IP address represents network, if it is a 1. And what is the second bit? Second bit is also 1. So if the second bit also 1, the second bit, the corresponding second bit of the IP address represents a network. And then what is this third bit? Third bit is 1 in subnet. So the corresponding third bit of IP address represents 1. So now how many ones we have in this? So we have first octet all are ones, second octet all are ones. So what does it mean in? What does it mean is, the first 2 octets of the IP address represents network. Network. This 2 belongs to network. So 15880, these 2 octets represent network. So now zeros has begun. So what does 0 means? 0 means if almost this one is 17th bit. 17th bit of subnet mask is 0. It does mean the corresponding 17th bit of IP address represents host. That's it. So now for all are 0 in subnet mask, third octet and fourth octet all are 0. It means this second, the third and fourth octet of IP address represents host. They identifies host. So now to make it simple, so this one, the first 2 octets of IP address talks about the identifies the network. Once you enter inside the network, then this many combinations you can have to identify your hosts. That's it. Okay, this is one example. I will practically explain the same thing in forthcoming sessions. So just to explain one more time, the first 16 digits of subnet mask are set to 1. Thus the first 16 bits of address 158.80, the first 2 octets identifies the network, and then the last 16 bits of the subnet mask are set to 0. Thus the last 16 bits of the address, that is the third and fourth octet of the IPv4 address, that is 164.3, identify the unique host on the network. So the network portion of the subnet mask must be contiguous. For example, if you want to take 255.0.0.255, that is absolutely not valid. So this kind of thing is not valid. So first two should be at least 2 octets should be given for the network identification. So